Hi, my name is Justin Chew from class PE06.
This circuit is supposed to acquire the sound output from a stethoscope, which completes to be a biomedical signal processing system. In stage 1, IC TL072 is a dual low noise JFET input general purpose operational amplifier. It supplies a voltage gain which is generally somewhere between 10 mV to 1 volt but does not provide any current. The op-amp amplifies the sound where subtle shades in the character of sound can be added or subtracted. So based on this circuit, it is a fixed gain closed loop non-inverting op-amp, and the circuit needs to bring the signal from an electro microphone up to a level suitable for a line input. Capacitor C1 at 10 microfarad blocks the DC bias voltage from the input voltage divider, consisting of two 10K resistors provide half of the supply voltage, which supplies the op-amp to be working at single supply mode, in this case at 4.5 volts. The resistors R2 and R3 and the capacitor C2 and C3 form the bandpass filter band gain, which is at 23, using the formula 1 plus R2 divided by R1, and the coupling capacitor C4 at 10 microfarad couples the output from the first amplifier. So if any DC input offset were amplified, it would cause a larger output offset, pushing the output towards one of the rails and reducing headroom. In other words, the output waveform will be cut. Hence, capacitor C4 passes the AC signal while blocking DC based on this table for the amplifier. Stage 1, we can see that as the frequency increases, the gain will also increase until its maximum of 23, as per calculated earlier. On its frequency will be at 100 Hz, and the frequency higher than 100 Hz will cause the gain to drop. To set up stage 1, we need to connect the power supply DC source to the circuit and make sure it is at 9 volts. Then secondly, the function generator frequency needs to be set to sine wave 1 kHz at 200 mV peak to peak. We do that by connecting channel 1's probe of the oscilloscope to the function generator by pushing the negative 20 decibel attenuator and altering the amplitude using the turning button. We can get 4 boxes multiplied by 50 mV per division, which give us 200 mV peak to peak. By placing the probe of channel 1 to test point 1, we can see that the output voltage is at 200 mV peak to peak. Keeping test point 1 to channel 1, and by placing the probe of channel 2 to test point 2, we can get our sine waves for both test point 1 and test point 2. For ICA2, it shares the same IC, which is the TL072 IC, as the first stage, and it is a negative feedback loop amplifier, and the negative feedback is the process whereby a portion of the output voltage of an amplifier is returned to the input with a phase inversion known as 180 degrees out of phase. Hence, the trimmer controls the feedback signal that can reduce the overall gain of the amplifier, which can function as a linear amplifier and will not saturate the output voltage. A voltage divider consisting of resistors R9 and R10, they are 10K ohm each, are connected to pin 5 of the TL072 IC, and it is not only to provide the op-amp to be working at single supply mode, but it also acts as a level shifter so that the output will not be clipped. To set up stage 2, we will put the output of test point 2 at channel 1, and all the frequency and power supply, we will not change it. We will then place the oscilloscope at channel 2 to test point 3, and by turning the trimmer, we can see how it affects the output waveform, and as I adjust the trimmer, the waveform will be amplified and at some point become saturated and cut off. In stage 3, capacitor C5 at 10 microfarad will block out DC and allow AC to pass through a voltage divider consisting of resistor R11 and R12, which is both 10K ohms. It acts as a single supply mode for the second IC TL072, and it also acts as a level shifter to make sure no output is being clipped. It is patched as a Sallen-Key second order low pass filter, and it is made up of two low pass RC networks. Capacitor C7 will provide the feedback for shaping the response near the edge of the pass band. It allows low frequency to pass through while filtering out the high frequency. An output voltage from IC2A will then pass through capacitor C8 at 10 microfarad to filter out any DC, as the lowest frequency that can be passed through is 0 Hz. The bandwidth will be equal to the cutoff frequency given by this equation based on the table. We can conclude that when the frequency is below 500 Hz, the filter is at unity gain. But once the frequency is above 500 Hz, gain and the output voltage will start to drop. For stage 3, we will keep test point 3 at channel 1, and we will not change the place we put our function generator and our power supply. And then we can place channel 2's probe of the oscilloscope to test point 4. The waveform at test point 4 will be determined by output at test point 3. So, by adjusting the trimmer at stage 2, it can also control the output at test point 4, as mentioned earlier on. When frequency is below 500 Hz, the amplifier will be at unity gain, which is the gain of 1, which means it will be equal to the input voltage. However, in this case, the unity gain is not applicable as the frequency is set at 1000 Hz. Hence, there is a drop of output voltage from test point 3 to test point 4. Therefore, final output will be the maximum sine wave attained without being saturated. In the final stage, we use IC-LM386N-1 as IC3, and it is being used as an audio amplifier that drives a speaker, and it is designed to be working in a single supply mode internally. Hence, no additional voltage divider is required, and it is the only amplifier in the whole circuit that drives current to power up the speaker. Capacitor C15 filters out high frequency that is above 40 kHz. Without it, the output waveform will be slightly unstable. Capacitor C13 will then block out DC and allow AC to pass through. The input will first go through the trimmer P2, where pin E has a full amplitude, while pin A and S has 0 amplitude of the input waveform. To set up stage 4, we will do the same by keeping test point 4 at channel 1, and then we will place channel 2's probe of the oscilloscope to test point 5. We will then change the function generator to be at trimmer P2 at point E. Thank you for watching my video.